Okay, question 2.1. The instruction there is simplify fully without using a calculator. Okay, so what we would do here is at the bottom, we would take out the highest common factor. So this minus split systems, one term, that's another term. So between the two terms, we take out the common factor. Okay, let's just rewrite the numerator again. So the common factor at the bottom is 10 to the power of a. So that means I'm left with 1 minus, if I divide this by 10 to the power a, I'm left with 10 to the power negative 1 times 2. Okay. So this 10 to the power a, I can also, the 10, I can write as 5 times 2 to the power of a. And that is, inside the bracket, that would be 1 minus 1 to the power of negative 1 is the same as 1 over 10. And that is times 2. Okay. Okay, so from laws of exponents, the a belongs to everything inside the bracket now. So that's going to be 5 to the power a times 2 to the power a times, okay, so we have, that would be 2 tenths. And if I say 1 minus 2 tenths, that would be 8 tenths. Okay. Right, so laws of exponents, when we've got the same basis and we're dividing, we would subtract exponents now. So if I subtract a from a minus 2, I'll just be left with 5 to the power negative 2, because that a's would cancel. And here, with a base of 2, if I subtract a plus 2 minus a, I'll just be left with 2 to the power 2. And then below the line, I'm left with 8 over 10. So 5 to the power of negative 2 is 1 over 25. 2 squared is 4. And I've got 8 over 10 at the bottom. So if I multiply the 1 over 25 times 4, that would be 4 over 25. And now because I'm dividing fractions, I can tip and times. So I can times by, but now I just need to tip this. So that's going to be 10 over 8. So now multiply numerators with numerators. That's 40 over 8 times 25 is 200. That's 4 over 20. If I simplify that further, that's a fifth. Okay, and that was worth 5 marks. Okay, 2.2. Solve for x without using a calculator. So you've got x to the power of negative 3 over 4 is equal to 8. First thing you do, so this is in exponential form, so you want to write the 8 also in exponential form. So 8 is the same as 2 to the power 3. And now I want to solve for x. So I want to get rid of this fraction. I just want x to be to the power of 1. So to do that, I need to multiply by its inverse. So I multiply by negative 4 over 3, but then I have to do the same on this side. So that's going to end up being 12 over 12, which is the same as 1. And here, 3 times 4 is 12. 3 times negative 4 is negative 12, divided by 3 is negative 4, so that's 2 to the power negative 4. So x is 2 to the power negative 4 is 1 over 16. Alright, next one, 2.2.2. We've got 4 to the power x minus 2 to the power x is equal to 2. So we can write 4 also as a base of 2, so that's going to be 2 to the power 2x minus 2 to the power x minus is equal to 2. So now all the bases are the same, and 2 will have an exponent of 1. So now I can equate the exponents to each other. So therefore, I'll have 2x minus x is equal to 1. 2x minus x is x. X is equal to, x is equal to 1. Okay, next one, 2.3. Okay, so let me show you there. So they said if x is all of that and y is all of that, determine the value of x plus y squared. So what we need to do is we need to go and substitute these expressions in the place of x and y. No? Okay, so let's do that. So we've got 3 minus square root a over square root 2 plus 4 plus square root a over square root 2, and that needs to be squared. Yeah? So let me just put it here on top so that they said it was x plus y squared. We must find the solution of x plus y squared. So we're going to go substitute x, we're going to go substitute y. Okay, but now because both the denominators are the same, that means I can add the numerators. No? So 3 plus 4 is 7, and negative root a plus root a would cancel each other out. No? So that means I'm just left with 7 over root 2 squared. Then I need to square 7. Square of 7 is 49. The square of square root 2 is just 2. Né? If you left your answer like that, I would also have been happy with that. Or we can simplify it further. 48, so that would be 24 and a half. Okay, so it looked very intimidating, but actually it wasn't. No? If you substituted, you would have seen, okay, but the denominators are the same. And if I add fractions with the same denominator, I can add the numerators. And then it just came down to that, which I need to square. Okay, the next one. I know you guys have seen this one. I think even more than once, no? Okay. So we need to show without using a calculator that all of this will equal to 120. So first thing we do is we're going to split these values into a perfect square and another number. No? Okay. So let's rewrite that as is. That we can split into 64 times 10. 81 times 10, and that one is 4 times 10. Okay. Sorry, 12. So the sixth root of 64 is 2, so that will come outside the root. The fourth root of 81 is 3. It comes outside. And the square root of 4 is 2. That comes outside. And now I'm going to write this in exponential form. So that's going to be 10 to the power of 1 over 12 times 2 times 10 to the power of 1 over 6 times 3 times 10 to the power of 1 over 4 times 2 times 10 to the power of 1 over 2. And then the fractions I can write as a denominator of 12, so that's going to be 2 over 12. That will be 3 over 12. And that will be 6 over 12. Okay, now I'm going to multiply these numbers. It doesn't have the base 10s, just these constants. So 2 times 3 is 6 times 2 is 12. And then if I add all these fractions together, so we've got a base of 10. Law of exponents says if I have the same base, I'm going to add the exponents. If I add up all the exponents, that's going to give me 12 over 12, which is the same as 1. So that's going to be 12 times 10, which is 120.